Hello everyone. So this video is to show you a small circuit which I made to basically allow you to run battery capacity tests with constant current load and regen option. So basically you can run this typical battery discharge test to measure the capacity of the battery, and at the same time transfer the energy of the measuring the battery that you want to measure to an empty battery. In this way you don't only don't waste the energy of your battery that you are measuring, but also you don't need to deal with this heating a resistor and then need to have some kind of fan to cool down everything, especially when you are testing many batteries. So the concept is very simple. I can control the charge flow or the current of the battery I'm discharging by having a very fast switch, like a MOSFET, switching on and off very fast. And essentially I can control the amount of charge by controlling the duty cycle of the MOSFET, so the ratio of time that the MOSFET is on or off, the switch is on or off. And then, since this switching method for achieving constant current load, it's basically very similar to what you will do to build a boost converter. If you combine now a coil, an inductor, with the MOSFET and a diode, effectively you have a boost converter, and you can increase the voltage of the battery that you are discharging in order to charge another battery, right? So this is the circuit. You can control the modulation or the switching on and off of your MOSFET with a microcontroller like Arduino or anything else, but just for the purpose of having the whole circuit very compact and easily integratable with other kind of battery capacity testers, I wanted to have everything in an analog form. So basically I use an op-amp, operational amplifier, and a module that I can measure the current flow. This is an ACS 712 module that measures the current, and it gives the value as an output that refers to a voltage. So now basically I can use the op-amp and compare the output voltage from the current sensor, and use a tripod to set a reference voltage that will represent the current flow that I want. And whenever the op-amp compares those two and you have reached the value of the current with your current measurement module, it will switch on and off switch on or off the MOSFET. And this continuous process, it can give you the constant current that you want, but at the same time the coil and the diode with the MOSFET will boost the whole thing up so you can charge any kind of battery. So when I was building this kind of setup, I had two problems in mind that I wanted to solve. One problem is effectively I wanted to be able to control my current discharge rate at whatever is needed, so you can have flexible discharge rate to whatever kind of batteries. It can be half amp, 1 amp, 2 amps. I didn't want to have any limitation to this, and that's why I built this. You could basically essentially use a simple boost module, right? So you can have your battery that you want to run the discharge test here, and the battery you want to charge here, put your potentiometer to the highest current. But the thing is, usually the inductors in these modules are very small, and you have a lot of losses and quite a lot of heating because of high resistivity. And in general, so I tried a few things, but this module I couldn't, for instance, go more than 0.8 amps discharge rate. So with this thing now, because I switch on and off things my way, I can basically have no limitations. So this was one of my problems that I want to solve, and the second problem was the efficiency. So I tried different methods to achieve this energy transfer and battery capacitance tests, and usually I had troubles getting more than 60% efficiency of the transfer. But with this circuit and using a conductor with thick wire, so you have the loss very low resistance losses, I can get efficiencies of more than 70%. So depends the state of charge that your batteries are. You can be something between 72 and 78. So here now I'm just gonna quickly run a test so we can see how the circuit works, and we can also see the efficiencies. So these are power meters, and we can measure the total power that comes out from our discharging battery, and how much of this energy will end up in our battery generation battery. And I use these two identical power meters, so basically we can measure the efficiency as accurate as possible. And then to control my discharging process, you can use any kind of tool that you have to limit the discharge voltage of your battery, or put a cutoff voltage. I'm just use the cheapest thing you can buy. This is the ZB2L3 module, and basically I can show you how the circuit works. So first you need to put your battery, which is empty, right? So you see it's at 3.6 volt, so it's a little bit lower than 40% charged. And you should be careful that the battery that you want to transfer the energy to has to be empty and its capacity way larger than the battery you are discharging. Or you should have some kind of protection circuit, which if this battery goes beyond 4.2 volts or its maximum voltage, you can actually stop the whole discharging process, right? But this is just to test the whole thing. And so here we are. Now I can add my battery where I will run my tests, and we see that this battery is at 4.1 volts, so it's almost 100% charged. And I can go and zero my power modules, so 0 amp hours, 0 watt hours, and same thing with the one that we measure how much energy we transferred, like this. And we can go and set the cutoff voltage for the discharged battery with the discharging measurement module, and we can press OK. So now my circuit is off, so no current will flow from my discharged battery to the charged battery. But then I can turn on simply my circuit on, and you can immediately see that now we are outputting 0.8 amps from this battery. The voltage is approximately 3.9 volts, so this is a little bit offset. but hopefully the difference in power is accounted from both of those. So we can see that we are discharging the battery with a rate of 0.81 amps, and we transfer 0.59 amps in this other battery. So I will put a little bit this to run here in fast forward mode, and we can come and see what the efficiencies after a while will be. But essentially you will see a difference in efficiency when the battery that you discharge voltage is higher than the battery that you transfer the energy. The efficiency will be slightly higher compared to the efficiency that you will have when this discharging battery voltage is much lower than the battery that you are charging. Okay. But what is important here is that basically I can go and change very simply the rate of discharging by simply tuning my potentiometer. You can see I can go from 0.03 all the way up to 1 amp. .2, so there is no limit. I'm not going to go any higher. So, but basically, really, I didn't find any limitation in this circuit. So I'll set up at 0.8 volts and I will let it run to measure the efficiencies. So we are now constantly, I set it up to discharge at 0.83 amps, and we see that we are putting in the other battery 8.6 watts. And basically you should measure the efficiency in terms of power. So we are outputting approximately 3 watts, and we transfer to the other battery 2.2 or 2.24. So this is approximately approximately 74% efficiency. So I will let this run for a little while and fast forward just to come back and see the efficiency after a while. stop the process. So we see now that we extracted from our discharging battery approximately 0.58 amps, and we put to the regen battery 0.39 amps. So this is, I think, pretty reasonable efficiency. Okay, so I will here I can show you the schematic of the circuit. Hopefully this can be integrated to anything. Thanks for watching.